This edition of Pipeline Things, we bring in our guest, Tim Malley, to talk about composites. It's a lot of fun. And if you're like me, I think you're really going to enjoy some of the topics we dive into, which includes installation issues, includes when and where to use composites, and maybe some of the challenges, while Chris stuffs his face with chocolates. Thanks for joining us. Boom! Welcome to this edition of Pipeline Things. I am your host, Rhett Dotson, my co-host, Christopher DeLeon. And here we are today. We have a, actually, I'm kind of excited about this topic, Chris, because...
I'm excited about our guest.
Look, I'm excited about the guest and the topic, right?
I'm more excited about the guest.
More excited about the guest?
Yeah.
I think, okay, well, look,
The guest
we can
is
come
the
at
show.
it from different...
The guest is the show, bro.
I'm the show.
The big show.
Can we edit that out, Mr. Producer?
No,
Is that
you
editable?
cannot. Keep
Oh.
going. Let's roll.
Yeah, you guys know we're doing it live. So, Chris, the reason I'm excited is because, I mean, this is like a big part of our industry, but we haven't really talked about it yet on the show. And that always makes me, excited. I also think that this is an example where I feel like so much information and so much out there that for me personally, I think it raises a lot of questions about, you know, what decision I would make, for instance, if I were an operator. And that's why I'm excited about the topic. But
making decisions is hard.
it is. You know what else is hard?
Do you know how hard it is to make a decision?
Yes.
Aren't you remodeling your house or doing some work at your house?
No, it's not remodeling our house. Thanks for bringing
You're
it up.
remodeling the landscaping.
You're
doing
redoing
landscaping work,
yes.
right? You're
And
making, because Houston allows for beautiful weather.
Yes. Let me
Right?
explain how that conversation goes, Chris.
Okay.
My wife has handled all that. Thank you very much, Lovely Morgan, for handling that. But she comes to me and she's like, Rhett, which plants do we choose? To which I'm like,
The pretty ones. The pretty ones.
I didn't say it that way. I think the exact words, different
Whatever
interpretation.
you want, honey.
I think it was more like, I don't care. So-
You never care. You're going to care about that bill.
Well, then she showed me at least 3 or 4 different pictures of different types of plants, to which my response was still, I don't know.
Oh, God.
And I was like,
Has she picked yet?
ultimately, I did give her some guidance. I think it might even
Potter's
be
weeds?
applicable to today's.
Potter's weeds?
Is it pot or weed? No, I didn't grow pot.
Potter's weed? No?
I don't know what that is.
Oh,
brother.
salvias?
I don't know. Why are you
No?
asking me this? I clearly
These are
don't know.
beautiful plants.
only thing
they're great. Did you? Okay, how about pansies? You know that saying when you were a kid,
She
don't
doesn't
be
like
a pansy.
pansies. She doesn't like pansies. I do
Okay.
remember that one. And we had an option for knockout roses.
Yes, you don't
And
want knockouts.
she
Please
did
don't put
not.
those in.
Nope,
Yeah,
I
those are.
didn't.
Amanda hates knockout roses. We
What-
put a bunch in and ripped them out.
My final advice to Morgan was, love, whatever won't die.
That
That's
means-
what I want.
That means it's all green, no colors.
Well, it turns out we put in a whole bunch of stuff. Look, and I don't remember. And one of them definitely did not get watered, and at least 2 of the bushes are dead. But that's neither here nor
So you
there.
have made these choices.
Oh yeah,
these
they
are
were
done.
made. Don't ask me what was made. It's.
Did you
in
get the
in
foxtail
right now.
bottle brushes? Those are cool, dude.
I wouldn't know. Why? Are you, again,
You should
point-
have had Morgan tell
The
me this
whole
stuff. Like, we
point
could
of
have done
this
this, bro.
segue was I do not know, and I still do
I
not
feel like you feel like that
know.
with a lot of things sometimes, right? How do you feel about composites?
Well, that's going to be the subject of today. So, without further ado, we're going to bring on our guest. So our guest is Mr. Tim Malley. And so I've known Tim for, man, it feels like a hot minute. At least, I see I'm going to get it wrong. Tim, because I was going to guess which company you were with when I first met you. And I was like, oh, I'm probably going to guess the wrong one. So I think
Let's
it's
hear it,
best.
guys. Let's go for it.
I was going to, it's NRI?
No,
No.
I'm just gonna wing it. I was gonna go with Clock Spring.
No, it wasn't Clock Spring. Definitely not
See,
Clock Spring.
but I didn't meet you that
This
long
is
ago.
fun.
I feel
I
like
think
I met you maybe
was-
5-ish years ago, roughly. Was about when you and I met.
I was with
It's,
Clock Spring
it's
then.
CSNRI, and
Uh-huh.
that's what I was thinking. But it wasn't NRI. There was another company in the middle of there that got bought, and I can't remember what the name of that one is.
Citadel.
All right, Tim,
Was
please
it Citadel?
Introduce yourself.
Was it Citadel?
It was Citadel.
Oh, there you
go. Yeah.
Introduce yourself. Please tell the audience a little bit about you.
Yeah. Well, thank you guys for having me. I'm excited to be the first person to introduce composites on your show.
Yes,
You are. You're
That's
the first one who
intentional,
wanted to
because
take.
we bring people on the show that we like, so that means a lot, bud.
I appreciate
Welcome
that.
to the show.
You did call me Travis Kelsey at the PPIM
I was wondering
of
where that was going to
composites.
come up.
Yeah,
I was
here it
wondering-
is right now.
Hey,
He's looking pretty old
Yeah,
and
it's not
battered.
working right now.
I'm thinking I'm hitting my prime right now. So
Wow.
Unlike Travis Kelce of like 10 years ago.
Yeah. Even up to like 3 years ago, bro. Yeah. Not a bad trajectory, just not where he is at a stage in his life.
Yeah, exactly. He's doing too much podcasting. So Tim Malley, I got my degree in mechanical engineering in 2010. That was not a great time to get a job. And my only offer out of school was with Citadel Technologies. They made a carbon fiber and epoxy composite repair system. And I did a lot of design engineering for them. So design engineering, testing, quality assurance, really learned a lot of what goes into making a composite. It took me all over the world, so it's been a pretty dynamic and fun position. I went to some pretty crazy places. Went to Libya about 9 months after the Benghazi attacks happened because they needed some pipe repaired over there. I would not want to go too far down the safety path on that, but that's just one of many, many places that this this fun realm has taken me. So
I can parallel that. Pipelines can find a way to take you to some pretty cool places.
Yeah.
Oh, yeah.
I think there's a lot of people that would align with that, whether it's domestic or international. Like, I feel like that theme is legit.
It's just funny. I had lunch today with somebody, and I think they're a listener, so they'll appreciate this. And this individual told me they just spent their first time on the right of way, and I was like, "How did that go?" And they were like, "Dude, it was like the bushes were above my eyes. I was parting ways. There were snakes on the right of way. I was totally unprepared for this." So anyway, all right. So Tim, here's why I'm excited to talk to you. I'm hoping that in this episode, and I'm hoping for our listeners, you can help cut to the chase on what would really be sound recommendations for when and where composites make sense. Because in my own, again, I've been dealing with composites or surrounded by them for at least the last 14 years. And I feel like there's one camp that is you can use composites everywhere for anything in virtually any scenario, regardless of the stress or the load or the threat. And I know for certain, absolutely, that cannot be true, right? I don't care what lab testing or otherwise was done to say that. I really want to know I'm hoping to get from you, when and where, in your opinion, let's just start there, are the strongest use cases for composites, you would say?
Well, I do want to address an elephant in the room.
What's
I would
the
say the elephant is that there's a pretty big industry-wide push kind of towards B sleeves right now. And I completely get that. But I want to say that as a tool and as an industry, you need options walking into every ditch. Like every ditch is going to present a very different, unique circumstance. I mean, you've got just issues with the right-of-way, like you just talked about with the snakes and the bushes. You've got issues with maybe you were out on an EMAT dig and you uncovered a wrinkle. All of a sudden, what you walked into that ditch with, looking with a B sleeve, you don't have that same option anymore.
Yeah.
So
and that's
composites
useful.
are a tool. They're a tool to be used in the right scenarios.
And so some of those scenarios, I like how you went with my question. It's a better version of it, Tim. There are some limitations. Maybe it's easier to approach it that way, because I do agree. I almost want to ask you why on the Type B, but that's for another episode. I do feel like there's been a shift towards that recently, but it is fair to say there are limitations on Type B. Geometric irregularities, certainly protruding, make Type Bs very difficult, or you end up with a pumpkin, which isn't desirable.
You want to have an option.
Yeah, or you can have very thin wall. Mm-hmm. Very thin wall creates welder issues for Type B. So there's 100% a place for composites in the industry. So let's start from there then. So when you have it as a place, where are they really effective? Where in your mind do composites shine?
I'm going to answer that question with a question. Do you know what the regulations say on alternative repair methods right now? I'll even give you the reference, 192.714.
All right, so we have a regulatory expert in the room.
Oh, I'm not an expert.
Yeah, it's Chris.
I'm not an expert. But my guess would be as long as it's passed valid engineering testing, as long as it's been designed and tested by legitimate analysis.
I'm sorry, I was trying to Google.
You're asking Siri?
I was trying to Siri.
I'm curious what ChatGPT would say about that.
We can find out, but no, Tim, please enlighten us.
I'm assuming it's here's my guess. It's an approved method, is something that has been tested by SMEs and is appropriate for the defect type. It would be my guess.
Yeah, right now, very close. Yeah. Right now it says your alternative repair method must be through technically proven engineering tests and analyses shown to permanently restore the MAOP of the pipeline.
Permanent. Is that we missed an opportunity? We should have
do
asked
it.
him. We should have
Go.
asked him. No, I'm not going to do that.
No,
I was
do
gonna,
it. Why
I
would
We
you
didn't go here
not?
in the prep, but I'm ready.
No.
Let's do it.
The fun question would have been, what part of that do you think is the most important?
Oh, that's fair.
That's what I would ask, because you've been doing this a long time. What part of all of that statement do you think is the most important for an operator to consider when they're choosing their repair type?
Let's assume that you all agree in the room.
Let's assume
what permanent is.
Let's assume nobody in the room
Oh,
has
that's
an
fair.
opinion, and
That's
it's
fair.
only us in the room.
That's fair.
Sarah.
We don't give out her real name.
Are we
It's Miss
recording this?
Producer. Oh my gosh. We're going to need you to edit that.
I need new rules.
No. Yeah. So let's get to that, right? So what part of that do you think is the most important part? Because you touched on a lot of things, right? In that
I think the
statement.
important part
Yeah.
are the technically proven engineering tests and analyses. So tests, analysis. A lot of testing has been done on composites over the last couple of decades or so, even back into the 90s when the clock spring was originally tested by the GRI.
Yeah.
And then a lot of advances in composite engineering, the materials that are used, the engineering behind how composite gets applied to specific anomaly types. But you want to have testing, and then you want to have analysis that shows why that testing performed the way it did and can extrapolate into the anomaly sizing that you're actually finding in the field and the material properties and the operating conditions of the pipeline itself.
So, easy example is corrosion, right? I mean,
Mhm.
like we've done tons with corrosion. We've shown that you can reinforce all the way up to the limits of B31G and you get great response.
Yep.
Right. You get, really full restoration of the pipe's original load carrying capacity. I think permanent, that's fair. You both deflected and answered that question at the same time, because I think it's fair. Look, we dealt with this with Brian. Like,
Oh, I'm happy to speak to it.
what is permanent?
Not what is permanent, but how to interpret 714 in that regard, right? And I think the idea there boils back down to you have to define and defend, which is the coined phrase that we got from Brian.
That's true.
And I also think that each operator, when they're determining how they're going to, I'm going to start with this word, how they're going to mitigate, I think that matters because every operator have a different philosophy.
Yeah.
And so if you're saying, I'm going to mitigate this through repair, then you have to think of, and we've talked about this before. Let me finish.
No,
Right?
you're good.
It's, am I mitigating or am I eliminating? Right. And for me, that's what you're kind of thinking about. And I think when we speak of the term, when we speak of repair, we get mixed in those two spheres of mitigating and eliminating. And so, for example, we would, if I may, for argument's sake,
You may.
we could assume a type B eliminates the threat of a defect, let's call it corrosion, if it's within the type B. I'm for this sake,
Okay.
we're going to say eliminates, because if it were to fail, it's supposedly contained because it's supposed to be pressure containing, right?
Okay.
Well, I'm generalizing,
All right.
right? Whereas if I were to choose, let's call it a type A, right? There is still a potential threat for corrosion if part of that repair method were to fail. So you could almost say, I'm not saying this is it. That's maybe more of not an elimination path. It's more of a remediation path, right? Or a mitigation path, right? So there's still some means of that failure coming, that threat coming back online. And so it makes me think about like what I just said, right? So what is the operator's posture for what a repair looks like? And is that repair mitigation or is it elimination? Yeah, that's my take. You asked me, well, you deflect. I was like, I didn't deflect.
No,
I
no,
just
no. I
didn't
said
get a
he
chance to speak to
deflected.
it.
I
I
don't.
was-
I don't want to poke holes in that, but I did listen to your podcast that you had with David Futch
Okay. Yeah.
about if type B sleeves are truly eliminating. You know, and there's a lot of variables that go into that,
Yeah.
and you want to control those procedures
Yep.
to make sure that doesn't happen.
Yeah. And the one with Futch was about permanency, guys. For those of you that are listening, you can go to our website, search Futch or such, permanency, and it'll come up. Continue.
So, in terms of composites, here's the big difference in the way that the industry looks at them right now. For a type B sleeve, you put it on, and to your point, most people are saying we're eliminating this threat. It's going to last indefinitely. And
That's not true. But yes. It lasting indefinitely.
Mhm.
I agree.
And I did
You-
just
we
listen
agree on
to
this point.
the Futch podcast,
Yeah, go ahead.
and they didn't even say indefinite in the podcast, so that's on me.
Okay. Oh no, I meant
I'm
I
a good
think
student, I
I
promise.
think you're right that the industry would use the word. I would disagree with even whether or not a type B is permanent, like forever. Nothing's
Right.
forever.
But-
But anyway, keep going.
But
You're doing
as
great.
it relates to how the industry looks at it and
Yeah.
accepts it and even gets
Perception.
inspected by regulators,
Perception.
it's accepted as
permanent.
permanent.
It's permanency.
Yeah.
So here's what a good composite should strive to do. It should strive to outlast a reasonable time frame of the pipeline's remaining life. So we put these pipelines in the ground how long ago? 60, 70 years ago, a lot of them. Everything what 60% of the
Let's call it-
pipelines are
70-ish would
pre-70.
encompass most of them.
You know what? That's a good question. I'm not sure what the average age of a pipeline is, but it's got to be north
pretty
of
old.
60. Okay.
And what was the
let's go.
design life of those pipelines when they originally got?
Indeterminate.
Was it?
I've actually never been asked that. Do you know?
I've asked this question a lot. I've heard 50 years a lot.
I wonder what they base that. Anyway, they weren't even doing
I
fatigue
don't have
calc,
all the
so
answers. These are just
That sounds made
It's
up, but
probably
let's
somewhat
go.
arbitrary.
asking people what their thoughts are.
I've
Yeah.
heard 100.
Yeah.
Okay, let's go.
I don't have a source for it.
They might not answer that now. Now it would be like, well, it depends on the function of integrity.
Forever. All right, let's go.
But how do we ensure the continued operation safely of those pipelines?
Yeah.
No,
Through an integrity management plan.
Yeah.
We inspect and we confirm, or if we can't inspect, we use other methods to confirm the continued validity of the operation of that pipeline. I would say with composites, you install it, when you properly design it, you should have it, for all intents and purposes, a discussion on the front end as you're looking to implement a composite of our pipelines in general. Like, we want to extend any anomaly by a minimum of this amount. And this is a regular conversation that we have with the operators that we currently do business with.
So, Chris,
and-
you see what's going on here?
It's an extension of life.
This guy's taking over the podcast.
He's
I'm
not.
asking
He's
questions.
doing a
and
great
he's just
job.
driving it.
He's a
his
guest.
own way.
You bring guests to your home to have fun. That's what he's doing. Let him work.
I'm the star of the show. No, Tim, you're doing great. I love that. So you're bringing in operators and you're framing a question. How much?
How long do you want this to last?
Yes.
Yeah.
Mhm.
Okay.
And there's
What are you trying to
there's
achieve
two,
is what
when
you're
you're
asking
designing
them.
a composite, there's two primary things that you want to look at. You want to look at the long-term strength of that composite, because there is a creep mechanism that can come into play with the composite strength if you don't design it properly.
When you say creep,
Uh-huh.
help us visualize what you're saying. Like, help me see what you're saying when you say strength and creep.
Creep is a loss of strength over time.
Got it.
So, like, if you've got a rubber band that ever stretched out to beyond its original,
yeah, not your neighbors.
All right. So we understand what you meant by strength and creep.
So a properly designed composite is going to know what those long-term strength properties of the material are, and ensure that that creep mechanism never comes into play by adding safety factors. So we're not taking the day one tensile strength and saying this is what we're going to use in all of our calculations. I say that we, as the universal we of composite world. The other mechanism that you would want to take a look at is cyclic fatigue. So for gas operators who don't have as much cyclic fatigue, you still want to run that analysis, but it's not going to be as big of a governing factor in your composite design.
And
For
I want to
liquids operators,
Mhm.
where you do have a lot more cyclic fatigue considerations, that's something that you want to include in your research on both your testing and your analyses, including the installation pressure.
All right. So what you're actually getting to, Chris, this is kind of relating it to the ILI world. You like to
Yeah.
talk essential variables.
yeah.
I
He's done
feel
that.
like where he's going, it's right to essential
Yeah.
variables. And I was actually going to ask the question, but he just went into it.
Yeah.
I felt like for the
Come on.
first time, I was going to have to raise my hand in my own podcast. So Tim, I want to make sure the audience understands that, right? So there's steady state and burst, right? And there's a lot of testing that's done on composites to address that.
Yep.
But that's only one part of the equation. That only
Correct.
says, hey, I can restore the strength up to this point.
Right.
What you're referring to is the fatigue component of certain types of threats.
Mhm.
And I want the audience to appreciate that, because what happens is the composite can restore the strength of the pipe, but if the pipe is still free to, let's say, expand
Free to
or
flex.
contract, I didn't want to use free to flex,
Flex mode, baby.
but if the pipe is free to
Yeah.
move under
This
the
is a no flex
composite,
zone, Tim.
it will go, Kelsey. It will that crack or that fatigue prone feature, it can still grow underneath it, right? And so what you're suggesting is that if fatigue is a consideration for your line, then installation pressure becomes an essential variable
Correct.
Mhm.
in the installation of the composite, whereas it might not be for something like, let's say, an ethane line or something like that.
Right.
Okay. Interesting. All right. And so y'all are getting into these conversations on the front end as well.
Mhm.
And so if you have a fatigue prone line, what's your general recommendation?
It depends.
It depends. Oh, he did
Favorite-
listen to the
He
Fudge
did listen to
episode,
Fudge's
100%.
podcast, yeah.
Favorite
And
engineering
Dr. Dave's
answer
too.
of all time.
Yeah.
Yes.
No, Metaler just responds.
Yeah.
We didn't tie his hand.
Is it something
I'm
along
not
the
a
lines, do you
metallurgist.
try and reduce the pressure as much as practical? Because I have had this argument with a close friend of mine too, because he's like, look, we can't bring the line down to 0.
Mhm.
But he's like, look, if we can cut the pressure in half, that's potentially an 8x fatigue life increase because you got a cubic component of the fatigue. And I was like, oh, that's fair. It's like, even if you can't bring the pressure all the way down to 0, right? That's what I don't want the audience to hear, is to use composites, you have to go down to 0. Is that ideal? Probably, but it's not necessary.
Composites won't get used, and I won't have a job if we wait for the line to go down to 0.
That's fair. And that's what I was getting at.
But there has been a lot of testing where the install pressure was at 0. So you do want to understand how the composite reacts to various types of threats when the installation pressure is not 0. And you should have an engineering analysis method that extrapolates that test data so that when you have a line, you have all of the pipe information, defect information, operating conditions that can go into an engineering assessment and allow you to create a design that works well.
Now, here's what I'm confused about. So you hit on a few of the essential variables. I don't know if we covered them all, but what was
I
kind
think
of
we're missing one that I'm curious about.
okay. I want to give you a chance to ask,
Yeah.
but I want to interrupt Chris. I want to interrupt Tim on this point, which is so Tim, you're talking about all this engineering assessment that's going into the design of these composites. And I'll be honest with you, I think it's surprising me a little bit because I feel like a lot of times it's repair people in the ditch. Hey, I need a composite, and they're slapping them on.
Yep.
Between the time when they're opening up the features in the ditch, when is this analysis taking place? Is this something that you guys are doing on the fly? Does this analysis take minutes, weeks, hours? I'm a little bit surprised at some of what you're saying.
Yeah, this is a great question, great discussion, because there are a lot of ways to do it. To your point, you can do a lot of this engineering analysis on the front end. So if you were going to take a look at the ILI data, like obviously that's what you use to select the digs that you're about to go excavate. Granted, there's tolerance on the ILI tool. There's even tolerance on the NDE methods, depending on what you're looking for in the ditch. But once you do a few different buckets, so let's add that tolerance to the plus side for sizing, making sure the composites are still applicable based, again, on that testing and analysis, then you can go out to the ditch with the plan, with material in hand, and that decision on how many layers and over what length can be separated into a pre-engineered design, if you will. So that can take into account all of the variables that we're talking about and separate it into a few different bucketed options.
So that you have all of your designs essentially before you go into the ditch, and then
Correct.
it's more like you're picking from a table. Got it. Okay,
That's
Chris,
that's one option, but there's other operators who they still want. They'll send that engineering assessment form into a design engineer. The design engineer will turn around a design package with all the variables that we just talked about, and that can be done within 30 minutes to a few hours. It's not a hard process, but the data collection is probably the most difficult and cumbersome part of the process.
So I remember, and maybe we'll answer this after the break.
You want to ask the question?
Yeah.
Is that the stage so you can think about it? Go
Since
for
you're kind of not hosting already, I'll kind of
Dude, I'm totally been
I'll
relegated.
kind of give you
I'm
a
like,
cue for when the break is coming.
This show brought to you by Tim Malley with guests Rhett Dotson and Christopher DeLeon.
I remember I was out on a ride away once, so I had the fortune of being able to see that whole life cycle, right, of threat management to assessment to call in repairs and then going out and seeing some of the repairs done, and that was pretty neat. And I remember I was out on one, and let's just call it, because I want to be a bit arbitrary here. The pipe was it was pretty old, and it had a coating type on it. And if you were going to go to where you found maybe some kind of condition of coating, you'd probably be digging for a while.
Mm-hmm.
And so I was like, how do you manage this interface? Right. So I've now surface prepped because I'm going to sleeve it. And I will admit it was an A sleeve. And so I was like, so I know this is a corrosion threat. How's the A sleeve mitigating? Because I didn't think it was eliminating the metal loss that existed. And they're like, we put this epoxy in there. I was like, okay. And then how to add the strength back because you've lost wall thickness. Like, that's where the steel sleeve comes in. I was like, great. I said, now, how do you manage the interface of where you've now sandblasted? There's no coating, and now you have a type A. And so for me, that was a big problem. I said, if we're going to really think about mitigating the thread that's under the sleeve, I need to understand what's happening around the sleeve. And so at that time, they had an approved matrix of what type of coatings you could put around the sleeve, and that would also interface with the existing coating type. So to my question, that's kind of setting the frame. I kind of think of the same thing with the composite, right? It's like I'm exposing the pipe, I'm doing surface prep, and you've mentioned the variable of strength and fatigue, but I feel like there's something else there, and it's how are we getting the wrap to stay on the pipe? Because if the wrap is not staying on the pipe, then I feel like that's something I need to design. I have to engineer that.
That does very.
And so is that where the break comes?
Yes, because it's
Okay.
you're gonna closely get into installation issues, which is where I want to go. With
So yeah, I
them
just want to talk
next.
about
He's taking it back, boys.
Taking it back.
He's
I am.
taking it back.
Give me the mantle. All right, to our audience, hang on. We're going to be right back while we get into surface prep and installation issues with our host, Tim Alley. Thanks. All right,
our
welcome
cue to
back,
go?
audience. Yeah, she
The
got
little
real.
clap thing,
Like, what do you know? You give her one thing, and the power goes straight to the head.
I've seen that before, by the
For
way.
our audience, we upgraded Miss Producer. We got her like an official director's thing now, and her attitude with that
It's totally
instrument in her
changed.
hands, yes, it's like Zeus with a thunderbolt, 100%, man. She went like all out. Can't wait till you guys see it at PPIM next week around.
Yeah, that's good.
So, audience, we're back with our guest Tim Malley from it's not CSNRI though, it's Hinkle, right?
We got bought by Hinkle. Yep.
Hinkle, right? And we've been. I'm enjoying this conversation, Tim. I gotta be. It's refreshing to talk to you, and I mean that. Like it for
Thanks.
me, this is genuinely enjoyable. So Chris started to ask a question at the end, but it went on for like 5 minutes. I know there was a question embedded in there, and I know it was directly going to feed into the discussion around installation, which is where I
The
want
importance
to
of
go.
adhesion.
But
Yes.
How
before he
important
does
is that?
that, yes,
Very.
We're there. Go for it, Tim.
It's nice because adhesion actually ties a lot of the things that we've been talking about together. So we talked about cyclic fatigue performance.
Okay.
And adhesion is one of those things that allows the composite to maintain bonded when you install with pressure, and then the pressure drops below that. And so that adhesion, yeah, you're right. It is something that you count on for that composite performance, especially in cyclic fatigue service.
Well, I was going to say even
I
more
mean,
than
it almost sounds critical. Without the adhesion, it's done. Because otherwise, how do you do in the
well,
load
no.
transfer,
So, like
right?
for instance, like no. Let me interface here. So, like when you think about reinforcing a corrosion feature for burst, the adhesion doesn't matter as much because the pipe is going to expand into the composite and engage it just because the pipe wants to expand, and it's going to run into the hard shell on the outside.
And then you can have electrolyte creep in between the interface.
Right. I'm saying
So again, adhesion is critical.
Adhesion is critical, but that what you just described wasn't addressed in the test that were done. In a lab
That's
test,
a
you
different.
put it on.
You're bringing up a different material. I'm
I
getting
am.
back to the essential variable of what do I
Agreed.
need to look
Okay.
out for as it functions.
All right.
Right. So it's not just load transfer; it's also its ability to mitigate what I'm repairing. And in this case, it's corrosion.
There you go.
Without adhesion, it falls apart.
All right.
You need to prevent moisture from getting to the
Water
surface of
ingress.
the pipe.
And we do that through.
through
The
the
adhesion.
resins that are used.
Gotcha.
Yeah, the adhesion of the resins that are used.
I
the
wasn't saying
composite.
it didn't matter. What I was saying is that you were describing a different behavioral mechanism, right? Which is more of an environmental mechanism than necessarily a load mechanism in that particular instance.
I guess what I was trying to get to for you to affirm is it's the adhesion is
Matters.
paramount because it does two things, right? It insulates the threat from the environment, right? So if you're having a time dependency based on some kind of corrosion mechanism, then that's how you keep the moisture out, right? And that impedes the ability of corrosion to continue to grow. So you stabilize it. But then it also allows for it to potentially make sure that the load transfer happens, right? So as you're cycling and the hoop stress changes and the pipe is expanding and not expanding, its ability to adhere to the pipe maintains or ensures that load transfer. Now, not in all cases, right? If it's at
Can I
72%,
geek out for a second?
please go for it, brother. That's what you're here for.
You're
homie.
the host. Take
Let's
it,
go.
man.
So there's a test program that happened in 2023 where we had very similar anomalies on 2 different spools of pipe, and we installed one at 0 psi and one at 50% smice.
Okay.
Ultimately, with a delta P of 10 to 72% smice for this program, going for 1,000 cycles to imitate, some gas service.
So it's about a 3-to-1. Okay, keep going.
So obviously, your min and your max strain on the defect is going to be different between installing at 0 psi and installing with 50% smice, because you already have strain in the defect when you're installing at 50% smice. But what is the more curious investigation point of this test was the delta strain with each cycle. You would imagine that when you have 50% smice install, that you're gonna have a lot higher delta strain per cycle compared to a 0% smice, right? Well, in this particular test, the delta strain was equal. The way that happened is because of the adhesion. So there is something that we're working on modeling right now and putting some FEA and some additional full-scale testing into, but to quantify this effect. But what we've seen so far is that because of the adhesion of a composite to the pipe, it will reduce, like you're going to have, when you go down to 0 psi, you're going to have positive strain in that defect. But ultimately what that means is over your delta P cycle, you're going to have the same delta strain per cycle for this particular anomaly and this particular test. I'm not applying this across the board, as installing at 0 psi.
So all we've done is reinforce adhesion is paramount.
Adhesion is paramount. Yes, correct.
And this look in my eyes, that skepticism. That you see so,
Keep it bonded.
Keep it bonded.
So with that, I think it feeds very nicely into, I think, what becomes a major concern for a lot of people that want to use composites. And I think it's a fitting place to end this particular conversation. And it's probably, maybe it's not the last time we talk, Tim. I've been hearing, my issue with installation is, I think for type B, people feel like, hey, a welder installs it and I can inspect the weld, right? And my welder is qualified. I know y'all have qualification on the install procedures, but I think there's some feeling of, hey, as long as I can check that weld, I feel good.
Mm-hmm.
And I've been hearing about how do we check composites or how do we handle installation issues? And I'm curious what progress has maybe been made, because I've not paid attention to this conversation over the last 10 years. But I know, because I've talked to people, there's numerous ways composites can install wrong, because the ditch doesn't look anything like the lab at all, right? And you've got temperature effects that come into play. You've got potentially weather effects that come into play. I mean, it's Friday afternoon. The
Human
temperature's
factors.
dropping. Ditch crew wants to get out of the ditch. It's 20 degrees. Let's just backfill it. In reality, that never sets up. And then it's like you just put putty on the pipeline. So I'm curious, what steps have been made to look at or address installation issues in the composite world? Or how would you respond to an operator who tells you, I don't want to use composites because of installation issues?
Yeah. So there is a big effort going on right now to continue to look at different quantifiable inspection methods to say this composite is good or this composite is not. And some of the issue in developing a technology like that, going into all those different abnormal operating conditions that you can walk into with different dishes, is that sometimes a composite that doesn't look good because, like you guys are ILI guys, because of filtration issues, right? Like maybe you don't have the right filtration on this NDE method, and that makes a composite look bad when in actuality it's good. So while we continue to develop those inspection paths to get to a quantifiable technology that allows us to go into each ditch, in the meantime, there's processes that have been developed to say, yeah, you've been through training. There's the operator qualification that you have to do. The installation steps are on a printed sheet. We call it the quality verification form. That's different for, I'm sure it's a different name for different composite manufacturers. But for the purpose of this conversation, quality verification form is going to list out the different steps of the application, what you're looking for with that step, and then having the trained installer initial each step of that process. And then at the very end, when you get through it all, you've done the curing portion of the resin for the composite, then there's a chart that says this is what good looks like and this is what bad looks like. So there's an acceptance and rejection criteria. And if it's rejected, there's another column that says this is the corrective action should this pop up. And so we get calls from the ditch quite often saying, hey, this is like a wrinkle or a bubble in the composite. What do we do? And we'll work through that corrective action to make sure, because that wrinkle or that bubble, it might go all the way down to the surface and could be an indication of a disbond at the bond line. Or it could just be that I don't have that load transfer because you're transferring through air, or it's imperfect or whatever. Sure. It's not good. So you need to remediate it before. So the goal is to get the contractors, the inspectors, the quality and the documentation processes, while we're waiting for that technology to continue to develop down the road, to get all of that quality assurance and documentation aligned and in a row in the meantime.
Do you feel like the composite industry is under a lot of scrutiny about the importance of installation?
Yeah.
Do you think other repair types are under the same level of scrutiny at installation?
That's a valid question, Chris.
No, but
I'm asking
I think
for
part of that.
It's a feel. Like, I didn't say is there a report out there. I'm saying, like,
Yeah.
I mean, this is what you do for a living, right?
It
You're
is.
out there, so you get feedback.
It's a great question. I don't know that I've ever been asked that question before.
Because here's what happens, right? Is like, we are really picky about why we feel like composites are qualified for certain repair types, right? And I go back to, it's like, you can put an A in, right? If you don't use enough epoxy and if you didn't fit it up right, there's no load transfer. It's the same challenge. You can have ingress of an electrolyte, which allows for the chemical process to continue, the corrosion cell to continue. And if you didn't fit it up right, you don't have load transfer, especially if there's not the right amount of epoxy.
I mean, I agree on that. Like that was something an expert told me once, right? Look, he's like, an improperly installed repair period doesn't work.
Yeah. And so we put all this emphasis on you guys of qualifying you. And I'm not trying to throw you a bone. I'm just saying, like, no. The question was, I feel like generally, since I've got a little bit involved around the composite guys, you guys are under a tremendous amount of scrutiny around, have you been tested? Who's validated you guys? Why do we think we could do this repair type?
Yep. And I would like to say that we accept that challenge and we want to raise
Had a good boy.
raise the bar and meet it, right?
Do you think y'all will?
I do.
Go ahead. I'm sorry.
No, I do want to say, one of the benefits is that even if for all these different repair types, let's say everything under the sun gets something missed in the installation of it, the benefit of a composite is that you're going to be able to see that issue on your next inspection run.
Yeah.
Because you can see under it, right?
Because you can see under it.
Like the magnetic, for the magnetic technology
and
in
ultrasonic.
particular.
Yeah.
And ultrasonics, but I mean, a type B is probably not going to have necessarily have the same problems that an ultrasonic, whereas magnetics for sure. I do definitely concede that, right? For sure, you get some advantages.
It's a nice safety check, right?
Yeah.
Well,
not to say you want to monitor everything.
So
but,
I mean,
it's
again,
nice to have that option.
We do everything
wait,
with the lens of: are we talking about integrity? Are we talking about safety? Or are we talking about compliance? Right. So that's kind of a theme we've been on lately. Is this a compliance mindset? Is this an integrity mindset? Is this a safety mindset?
I have two fun questions.
And I think that it's kind of like that journey, right? Of saying, hey, first we had to do a bunch of pig and digs. Then it went to, are we pigging and digging in the right place? And I feel like that's a lot of integrity management choices.
Yep.
And then that's kind of the path towards safety, which is, let's also make sure not we're just making good integrity choices, but we're keeping people safe.
Yeah.
And I would say, I do think your last comment there is very fair, because as an operator is installing composites or A's or B's, they need to understand what are the risk parameters of that remediation technique or that repair technique, whatever terminology you want to put on it, and then operate it as a system. If I know it's a corrosion flaw and I'm putting a composite on it and I did this 15 years ago, I probably shouldn't be turning an eye on all those that I think are repaired, and I should probably be looking and see what the most recent ILI run says. Right. So just a comment of, I think you guys are under a lot of scrutiny, and I appreciate your comment, but I do think that this is just one part of a broader system. If you're not replacing it, then you should also not just turn a blind eye to it either.
Right.
So, 2 questions. Do you think eventually y'all will get to something like an 1104 style criteria? When like 1104 has acceptable flaws and girth welds that you can move. Is that ultimately the goal of where you think y'all are going to try and get?
I would like that. Yeah.
Okay.
Absolutely.
Sec-
Personal goals,
Yeah.
which then may become industry goals
Yeah.
through podcasts like this. Shameless plug.
Shameless
Maybe
plug.
y'all should have
It's
a
almost like he's a
GIP on it.
host. Second question. Look, because Chris brought it up since he was talking about Type A's, and he's mentioned them. Tim, why would I do a composite over a Type A or vice versa? Can you give me a good answer for that? Or is there really functionally in your mind a difference between a Type A and a composite?
This comes in. I think that's where this comes in.
I didn't ask you the question. I asked Tim the question. Let's be quite clear.
I'm trying to alley-oop him.
He doesn't need an alley-oop.
Okay, fine. Never mind. Jeez, I'll try to do like
Travis
Kobe
Kelce
Shaq thing here.
grabs the ball and brings it into the end zone.
Well, I don't know that we're thinking the same thing, so let's hear what you have to say.
He
about
probably
this.
has a terrible answer. I'd rather hear yours.
Yeah, there you go. I'll just let it go. Go ahead. I was gonna let that one go.
I'm not here to talk bad on anything. As a composite, if you just want to take a look at some of the differences on how a Type A and a composite get installed, I would say that biggest difference is that bond of the adhesive of that composite over the entire surface of the repair zone. And that's going to be what you're counting on for, once the pipe drops below install pressure, that there's no potential gaps, because even if an external coating doesn't do its job, because you've got that bond to the pipe and you're not allowing any potential paths for moisture ingress. And then the second thing would be, it's kind of an easy softball, right? As you guys have talked about on previous podcasts, fit matters for your repair types.
Yes, that's good. That's valid
There's going to
point.
be a lot of areas where, as you're trying to do a not completely circular pipe and a not completely circular A-sleeve, where a wet wrap composite
Yeah.
can conform to the exact geometry.
Bends, other
So like a
things.
bend,
Yeah.
a wrinkle,
Gotcha.
those types of things are going to be obviously super easy softballs to choose a composite.
Yeah,
on.
no,
for,
that
me,
was
for
helpful.
me, that's where the box of chocolates come in. So for those of you that aren't on YouTube yet, Tim did a great job of bringing us some fancy chocolates. And it's got 36 different flavors.
Did you
in
open it up, make sure there's extra stuff in there,
I
and
did
not already
not.
eaten?
I trust him.
Chances are you could open it up. There's
I,
no
see,
like.
I would not know if I would trust you bringing us a box of chocolates, but I think I trust him. And my analogy is going to be, because if you've been in enough ditches, you never know what you're going to find until you see the pipe. And it feels a whole lot like this box of chocolates. And let's be real about that, right? It's like the ILI will call some things, but the tool won't always see everything, right? And so once you expose it, you might end up with like, hey, we've been here already. This looks great. And sometimes it's like, oh God, the A's not going to work here. What do I do, right? And I think that's kind of the role that you guys play. And actually, I'm curious. I mean, you guys have more than one solution, right? I mean, talk to us a little bit about the path of how you go from choosing between the different solutions we have.
Yeah, great question. So in general, I would say you could lump the choices into a few different options. Obviously, there's the rigid coil. And the rigid coil was the original composite because it was tested in the 90s.
The
The granddaddy. And it does have a lot of
Does Clock
successful
Spring ever
installations.
say,
Shut
you
up.
should have come to me first?
Just go.
Continue.
So that's one option. Then you've got your moisture activated systems. So that's a wet layup, typically a fiberglass, can be a carbon fiber. It's pre-impregnated in a lab, so you're removing the saturation variable from the field installation portion. And then you wrap that around. But typically those are going, both of those first two options I mentioned are going to be limited to metal loss and dents. If you're looking at the tests and analyses again, what they're appropriate for. Then you get into a carbon fiber and epoxy system. It's a wet layup. You're getting a dry carbon fiber. You're saturating that carbon fiber with a 2-part epoxy, and you're applying that in the field. That one is a little bit more applicable in terms of the amount of different anomalies that can be reinforced with it. And so if you're looking at stuff outside of metal loss and dents, you're going to automatically go to that.
Got it.
I was actually inspired, by different charts within the industry. They'll say like, this is the inspection we're trying to complete, and this is the ILI tool I want to use.
Oh, it's great.
And then you've got all the different
There's a
dots
bunch of
in that
different
big
ones
chart.
now. Yeah, it's a great marketing tool. You walk into operators' offices and you see them on the wall.
Yeah.
Yet I've never seen both competitors that have it out there have
they're
them
one or the
side by
other.
side. Like that would be really fun for an operator to have them side by side.
Do you have
do
one
the
for?
overlap.
Have you done one for the composites? Is that what
Yeah.
you have? You have like a corrosion feature and then a crack feature. And it's got the list of available.
Exactly. Yep.
That's awesome.
With the asterisk that it's depending on, the sizing and operating conditions, as we've been talking about.
So to our audience, you can email Mr. Malley if you would like to get that chart from
Were
him.
these for Sarah for us?
So why did
All
you
the
say her
above.
name? We never say her name.
Shut up.
All right. Tim, I want to thank you for joining us. Thanks for coming on. This is actually a really good conversation, and I enjoyed it. To our audience, I
Because
want
of
to
that, I'm
close
gonna get
off
the heart
before
one.
Chris
I'm gonna get the
shoves
heart
his
one,
mouth.
'cause
Thanks for joining us
we
on
love
this
that.
edition of Pipeline Things. See you again in 2 weeks.
Oh, that was like a Reese's. That was awesome.
This episode of Pipeline Things, executively produced by Sarah Etier, hosted by myself and Christopher De Leon. Special thanks to our guest, Tim Malley from Hinkle, and also to the Workwell where we filmed this episode.